Hello, my name is Marco. I came from the University of Beira Interior, and this presentation is about ongoing work intitulated Hybridization Effect on the Impact Properties of Flax Composites. Our research center is located in the city of Covilhã, which is located in the slope of the largest mountain in Portugal, the Serra da Estrela. And, of course, you are all invited to visit us. The motivation for this work comes naturally according to the problems that society faces. The demand for green solutions is a requirement to fight the ecological footprint in certain areas of the world. There are some green solutions for the production of composites with resins using a substantial part of vegetable origin carbonates, which, if related to natural fiber reinforcement, can present themselves as very promising solution. Fiber reinforced composites, especially those produced with natural fibers, have a limitation in their use due to their lack of toughness. Therefore, the solution to balance the mechanical properties of the composite is to introduce a small amount of synthetic fiber. In other words, the hybridization of the composite. So there are two clear goals in this work: the production of laminated composites and hybrid laminated composites, and the study of the mechanical properties of these composites, namely the influence of the hybridization on the impact behavior. These are the materials that we're gonna use in this work. For the matrix, we're gonna use a polymeric green epoxy, and for the reinforcement, we're gonna use a flax and a glass fiber, both bidirectional. These are the three main steps of the production of our composites. All of them have 8 layers of flax fiber, and the hybridization was made by the introduction of glass fiber in both sides of the composite, and then another 2 layers in the middle for the 2 times hybrid composite. In this slide, we can see the microscopic pictures of our composites. We can see the layers of the flax fiber, but also we can see on the middle and the picture on the right, the hybridization of the composite with the 4 layers of glass fiber and 6 layers of glass fiber. The stress-strain curve of the tensile tests show us that 2-time hybrid composites presents higher maximum stress resistance. The hybridization also increased the maximum stress over 26 and 35% for 1-time hybrid and 2-time hybrid composite respectively. The bending test results show us that 2 times hybrid composites presents a higher maximum flexural stress resistance, and the hybridization can increase 74 and 88% of the maximum stress for the 1-time hybrid and 2-time hybrid composite respectively. The microscopic images show us the typical damages that we have in our composites. We can see that there is some delaminations and fibers breakage here in the compressor zone. This fiber breakage, we can see that there is some differences between flax fibers and glass fibers. We can see in those images here in the right. For the impact characterization, we use a drop weight tower to perform a low velocity impact. Here we can see the scheme of the samples used in those tests and those dimensions. The impact tests were carried out considering not only the different kind of composites but also the different impact energies. In this slide, we can see the first impact results. The graphics represent a typical behavior occurred for flax laminates under different energies, and we can see that the load and energy present the same behavior for all energies. The load and energy increases up to a maximum value and followed by a drop after the peak load. The maximum load value represents the value that the composite laminate can tolerate before undergoing major damage, and this maximum load is very dependent on the impact energy. The curves on the left presents oscillations that, according to the literature, result from the elastic wave and are created by the vibrations of the material. The results indicates that load and energy versus time presents a typical behavior for all laminates. We can see that here in the load versus time graphic, the minimum average time was observed for the 2x hybrid composite, and the maximum contact time occurred for the composite with only flax fiber. We can also see that the absorbed energy step decreases with the introduction of the glass fiber. In this graphic, we can see the number of impacts until the failure occurs for the different levels of energy. We can see that for the same energy values, the 2x hybrid composite presents higher resistance. We can see here for 11 joules and here for 13 joules. We can also see that if we increase the energy level, we are decreasing the number of impacts, which means that the samples absorb less number of impacts until the failure occurs. This is valid for all composites. So we can conclude that it was successful produced laminate composites and hybrid laminate composites with different fibers, flax and glass fiber. We can also conclude that the stress tests evidence a 2x hybrid composites higher maximum stress resistance, both for tensile and bending stress tests. We can also conclude that the impact tests present us a maximum load dependence of the impact energy and hybridization. The minimum average compact time it was observed always to 2x hybrid laminates, and the absorbed energy decreases with the introduction of glass fibers, which means that our composites presents a higher stiffness for 2x hybrid laminates. So we can conclude that the hybridization proved to be a good solution to improve impact properties, but this conclusion must be validated by a multi-impact characterization. In the end, I would like to thank to all the co-workers and the institutions involved in this work. Thank you to watch this presentation. Thank you very much. Obrigado.